Welcome! STEM A Chip presents Control the Spin. In this video, we'll learn how to control the position of a servo motor by turning a potentiometer knob, all powered by the Arduino. A servo motor is a special type of motor that can move to exact angles, making it perfect for robotics and automation. The potentiometer acts like a dial or knob that you turn to tell the servo where to go. Using Arduino, we'll read how much you turn the potentiometer, convert that into a position, and make the servo move smoothly to that angle. With just a few wires and a simple command, you can make your servo motor move precisely to any angle. Let's get started and bring the spin under your control. Let's quickly go over the components you'll need for this project. An Arduino Uno, a breadboard, a servo motor, 10K ohm potentiometer, a USB cable, male-to-male jumper wire. Let's start by placing the breadboard on your workspace. Now, insert the potentiometer into the breadboard. Connect one side pin of the potentiometer to the power rail and the other side pin to the ground rail. Next, position the servo motor right next to the breadboard. Take a yellow male-to-male jumper wire and connect it to the servo's yellow wire, a red jumper wire to the servo's red wire, and a black jumper wire to the servo's black wire. Remember, the black wire is for ground, the red wire is for power, and the yellow wire carries the control signal. Connect the servo's red wire to the breadboard's power rail, place the Arduino Uno at the top of the breadboard, insert the servo's yellow signal wire into digital pin 9 on the Arduino, then connect the servo's black wire to one of the Arduino's GND pins. Next, connect the breadboard's power rail to the Arduino's 5-volt pin and the ground rail to any GND pin on the Arduino. Finally, to complete our wiring, connect the middle pin of the potentiometer to the Arduino's A0 analog input pin. Once all the wires are connected, plug in the USB cable to power the Arduino and connect it to your laptop. Now that the wiring is ready, let's bring our project to life with some code. Firstly, open up the Arduino IDE on your computer. Then go to Tools, then Board, and under Arduino AVR boards, select Arduino Uno. Next, go to Tools, then Port, and choose COM3, or another available port if COM3 doesn't connect. Once you've made these selections, you'll see the board and port details appear at the top of the Arduino IDE window. Let's start coding to make your servo spin control. At the very top, we bring in a special helper called the servo library. This is what lets our Arduino talk to the servo motor. Then we give our servo a name, My Servo. We also make a little box called val to store numbers from the potentiometer. In the setup, we tell the Arduino that our servo is plugged into pin 9 so it knows where to send the movement signals. In the loop, the Arduino first reads the position of the potentiometer, that's just a number between 0 and 1023. Next, we use a map magic trick to change that big range into angles between 0 degrees and 180 degrees so the servo understands. Then the Arduino tells the servo to turn to that exact angle. A tiny 15-millisecond pause gives the servo time to move before the loop starts over again. Once your code is ready, save it with Ctrl+S. Click the Verify button to compile your code and check for any errors. In case there are any errors, you'll see a message down below. Fix it up and try again. If the code compiles successfully without errors, you're good to go. Click Upload to send your instructions straight to the Arduino and get it running. As we turn the potentiometer knob, the servo motor follows along, smoothly spinning to match the angle we set. Turn the knob to the left and the servo moves back. Turn it to the right and it swings forward. It's like steering the servo by hand, giving you full control of the spin. If you enjoyed this project, hit like and subscribe to STEM A Chip for more beginner-friendly Arduino tutorials. Got questions or project ideas? Share them in the comments. We'd love to hear from you, and we might even feature them next time. Thanks for watching, and remember, with STEM A Chip, learning electronics is all about making motors move and ideas come alive.